Hello students, welcome you all to the video lecture on signals and system. Today we are going to see a problem on LTI system which is having the frequency response h of j omega equal to 1 by j omega plus 3 producing an output y of t equal to e power minus 3t u of t minus e power minus 4t u of t for a particular input x of t. We have to determine x of t. So generally they will give x of t and h of t, we will determine y of t. Here in a different way they have given the frequency response and also the output y of t. They are asking you to find out the input x of t. So from this term we can find out that it is a Fourier transform problem. That is, when we apply the Fourier transform to h of t only, we will obtain h of j omega. Okay. So we know the relationship that the frequency response h of j omega is given by y of j omega by x of j omega. So this is the relationship. Using this relationship we can find out what is the x of j omega, and once we have determined x of j omega we can easily find out the input x of t. Okay. So this is the relationship using your Fourier transform. That is, the Fourier transform of h of t is what? H of j omega, and h of j omega is given by y of j omega and x of, divided by x of j omega. In the problem they have given h of j omega, also they have given y of j omega. So let us determine from the formula that x of j omega is what? So take this term to the left hand side. So this term will go to the denominator in the right hand side. So numerator remains as it is, y of j omega divided by, take this term to the right hand side, h of j omega. So you can rewrite the formula as this, h of j omega equal to y of j omega by x of j omega. We are finding out this term, so take that to the left hand side. So this term will go to the right hand side. So y of j omega divided by x of j omega, and in the problem they have given y of t. Okay, so what is y of t? Y of t is e power minus 3t u of t minus e power minus 4t u of t. So using this you can find out what is y of j omega. So apply the Fourier transform. Okay, so it becomes y of j omega equal to, what is the Fourier transform of e power minus 3t u of t? So the Fourier transform of e power minus 8t u of t, the general formula is 1 by j omega plus a. So using that you can write that this term as 1 by j omega plus, so minus a means plus a, so minus 3 means plus 3. Okay, minus 1 by Fourier transform of this term. What is the Fourier transform of this term? 1 by j omega plus 4. Okay. So using this, once you have determined y of j omega, okay, we already know h of j omega. In the problem itself they have given h of j omega directly, which is nothing but 1 by j omega plus 3. Okay, so these two terms we have obtained. So we can find out x of j omega first. What is x of j omega? Y of j omega divided by h of j omega. What is y of j omega? 1 by j omega plus 3 minus 1 by j omega plus 4. Okay, all the terms in terms of j omega, divided by h of j omega is 1 by j omega plus 3. Okay, so let us simplify this term. So what happens here? Denominator anyway it remains same, nothing to worry about the denominator. Okay, numerator. Okay, so these two terms, when you see, these two terms are different terms, so take the common LCM as both the term, j omega plus 3 into j omega plus 4. So we are simplifying the numerator term. So both the terms are different, so take both the terms as LCM and cross multiply both the terms in the numerator. So j omega plus 4 will go here, j omega plus 4. Okay, minus of, take this term to the numerator here. Okay, so j omega plus 3. Okay, so numerator term is this, denominator term is this. Okay, so when you see the numerator, j omega plus 4 minus is applicable for both the term. So j omega plus 4 minus j omega, minus into minus plus, so minus 3 divided by j omega plus 3 into j omega plus 4. Okay, so denominator is this. Take the reciprocal of this term, so it goes to the numerator. So j omega plus 3 divided by 1. So 1 you can write or else you can leave. Okay, so take the reciprocal of this term. So j omega plus 3 will go to the numerator. So this term get cancelled. This term cancel. Okay, so it is in the multiplication with this term. Okay, so 4 minus 3 is nothing but 1 by, so this whole term becomes 1. So you are getting just 1 by j omega plus 4. Okay, this is your h of j omega. So h of j omega is 1 by j omega plus 4. So from this we have to find out inverse Fourier transform. So what is inverse Fourier transform? So 1 by j omega plus a means inverse Fourier is what? E power minus a t u of t. Okay, so Fourier inverse of 1 by j omega plus a is nothing but e power minus a t u of t. Similarly, instead of a we have 4 here. So Fourier inverse of x of j omega is denoted by x of t. X of t equal to 1 by j omega plus 4, 1 by j omega plus a. So a equal to 4. So e power minus 4t u of t. Okay, so this is the input x of t. Okay, are you getting? So here in the problem they have given h of j omega, y of j omega. You can easily find out x of j omega. So x of j omega you are finding out taking LCM everything. Okay, what are all the required terms? Take reciprocal properly and cancel out the necessary terms. So once you have done that, we have obtained x of j omega. From x of j omega we can easily find out inverse Fourier transform. Inverse Fourier transform of this term is nothing but e power minus 4t u of t. Okay, thank you. Thanks for watching.